Hi class, this is Sir Alex Vasco and welcome to our lesson in General Physics 2. Today we are going to discuss lesson 4, which is all about superposition principle. It is still related from the previous lesson, lesson 3, which is all about the Coulomb's law. In Coulomb's law, we basically learn how to measure the electric force if we have two charges. So for example, if you have Q1 and Q2, we can measure the force or the electric force that Q1 exerts on Q2 or Q2 exerts on Q1 by using the Coulomb's law. um, Coulomb's law is very effective if you're measuring 2-point charges. If we only have two charges, or if you have two spheres, two charged spheres, we can measure the electric force by basically multiplying the Coulomb's constant K to the product of the charges, of the absolute value charges of the point charges, and then divide it by the square of the distance. But this time, let's ask ourselves, what if we have more than two charge? How are we going to measure the electric force if we have more than two charges? That's where superposition principle enters. So at the end of today's lesson, what I want everyone to be able to do is for you guys to be able to calculate the net electric force. This time we're talking about net electric force because we're talking about multiple electric forces on a point of charge, so meaning we have one charge, and this charge is in a system where there are multiple point charges. So for example, if you have Q1, Q2, and Q3, so how can we measure the electric force that Q2 exerts on Q1 and Q3 exerts on Q1? So let's find out by first understanding what is superposition principle. So like I mentioned, we can measure the electric force between 2-point charges by using the Coulomb's law. In Coulomb's law, we know that the electric force, which is in units Newton because it's a type of force, is equals to the Coulomb's constant K, which is equal to 9 times 10 raised to 9 Newton meter per second over Coulomb squared. And we multiply that by the product of the absolute value of those two of the magnitude of the charge of those 2-point charges, and then divided by the square of their distance. This is all about Coulomb's law. But if we have Q1 and Q2 and Q3, so how are we going to solve that? What will be the new net force on Q1, or basically the force experienced by Q1 because of the presence of the charge of Q2 and the presence of the charged Q3? How are we going to do that? We can do that by using what we call the superposition principle. The superposition principle basically states that the total electric force of a particular charge experiences due to a number of other charges is the vector sum of all individual forces. What do we mean by that? Okay, so we have a particular charge. So we have one charge. So in this case, we have Q1. We can measure the total electric force that Q1 experiences because of the presence of Q2 and Q3 by simply measuring the force that Q2 exerts on Q1 and measure the force that Q3 exerts on Q1 and then add those. And it is important later we're going to discuss what do we mean by vector sum. Basically, vector addition, it's something that we've discussed in the beginning of physics. Physics 1, I hope you remember your vector addition and subtraction because we're going to go back there. Have you remember all those horizontal and those vertical components because we're going to go back there. Okay, so by measuring those forces, Q2, the force exerts by Q2 to Q1, and the force exerted by Q3 to Q1. And then using a vector sum, we can measure the total electric force. That's what basically the superposition principle is. In other words, or in layman terms, it's basically each of these charges will exert a force on the charge, meaning these charges will exert a force on this charge as if there are no other charge present. And it's the same way. You can also, because Q1 also exerts a force onto Q2 and Q3 exerts a force onto QT or Q2. But what you're going to do is basically choose one charge. Because if we measure all the charge being experienced by all this Q, it will take a long time to solve. So what we're going to do is if we have multiple charges, we're just going to simply take one and then we're going to measure the forces experienced by the Q1. Okay, now let's go ahead and try to measure and use superposition principle in various examples. So let's have move to our whiteboard here. Okay, so let's start with sample problem 1. Okay, so this is a simpler one. Okay, so we're dealing with just a straight line. Okay, so what we have here in our sample problem 4.1 is that we have 3-point charges. So these 3-point charges are arranged this way. So they're basically in a straight line. And it is shown that you may not see this, but this is actually Q2, this is Q1, and this is Q3. Okay, so Q1, so these 3-point charges are arranged this way, wherein Q2 is 0.5 meters away from Q1, and Q1 is 0.30 meters away from Q3. And we were also given the magnitude of the charges of each point charges. So you have for Q1 we have 4.0 times 10 raised to negative 9 coulombs. Q2 we have 5.0 times 10 raised to negative 9 coulombs. And Q3 we have negative 6.0 times 10 raised to negative 9 coulombs. Now they're asking what would be the net force on Q1 due to Q2 and Q3. So let's write that. Let's begin. Let's try and solve this by first writing our given. We are given that the point or the magnitude of the charge of Q1 is equal to 4.0 times 10 raised to negative 9 coulombs. Q2 has a magnitude of charge of 5.0 times 10 raised to negative 9 coulombs. And Q3 has a magnitude charge of negative 6.0 times 10 raised to negative 9 coulombs. Moreover, because of the picture right here, we also know that there are two distances. Okay, so let's write it this way. So we have distance between 2 and 1. So the distance between 2 and 1 is equals to 0.50 meters. We also have distance between 1 and 3. So let's write it this way. 1, 3. And it's equals to 0.030 meters. Okay. So now we have written all our givens. Let's write what is being asked of us. Ano ba yung tinatanong sa atin? From the problem, what they want to find is the force that is experienced by Q1. So yung force na experience ni Q1 because of the presence of Q2 and Q3. So find the net force on Q1. So basically the force that that experiences or that Q1 experiences. So it's the force that is on Q1 because of Q2 and Q3. So how are we going to solve this? Let's identify the formula that we have to use. From our discussion earlier, we've discussed that in order for us to measure the net force, what we need to do is identify that we need the superposition principle. And according to the superposition principle, to identify the net force that a point charge experience, what we need to do is find the force that the other charges are exerting on that point charge. So meaning we have to find the force that Q2 exerts on Q1. So what kind of force that Q2 exerts on Q1? And we have to find the charge or the force that Q3 exerts on Q1. How are we going to do that? Simply, we're going to use the Coulomb's law because in Coulomb's law, we can find magnitude of the electric force between two charged particles, and that's what we're trying to do. Only this time we're doing it twice, one for Q2 and one for Q3. So the force between Q1 and Q2 and the force between Q1 and Q3. So the first equation or formula that we're going to use is Coulomb's law, which is F is equals to K multiplied by the absolute value or the product of the absolute value of two charges divided by the square of their distance. Okay, so that's how we're going to find that. Next, well, the equation that we have to use is, since we're looking for net force. Net force is basically, it means the total force. So in order for us to find the total force, according to the superposition principle, we need the vector sum. So in this case, since they're all in a straight line, we can simply have to add the forces that is present or acting on Q1. So we have whatever how many force that we have. This could be 1, 2, or 3, etc. But in this case, we only have two forces. One that is acting from Q2 to Q1 and one that is acting from Q3 to Q1. So these are all the formula that we have to use. Now let's try and solve this equation. Solution. Okay, so let's begin by first finding the force that Q2 exerts on Q1. In order for us to be able to do that, what we're going to do is assume that the force that is acting on Q1 because of Q2, we can write it this way. So F2 on 1. So in this case, para hindi tayo malito. So this way, we're not going to get confused which force are we measuring. So first, we have to measure the force that Q2 is doing on Q1. Next, what we have to measure is also the force that 3 or Q3 is doing on Q1. So the force from 3 on 1. And how are we going to measure this? Again, we just have to use the Coulomb's law. So F2 on 1, let's move it this way. So F2 on 1 is basically equals to K multiplied by the absolute value of Q1 and Q2 divided by their distance. Same thing, K multiplied by Q1, Q3 divided by their distance. Okay, so let's solve for that. So we should know by now what the value of K is. K is constant. The value of K does not change. It will always be 9 times 10 raised to 9, not negative 9, just 9. 9 times 10 raised to 9 Newton meter squared per coulomb squared. Then the absolute value of Q1, which is 4.0 times 10 raised to negative 9 coulombs, multiplied by the charge, the absolute value of the charge of Q2, which is 5.0 times 10 raised to negative 9 coulombs. All of this divided by the distance between them. We know that the distance between 2 and 1 is 0.5 meters, and we have to square that. Okay, so let's plug, you just have to plug in that on your calculator. N2 is cancelled, so that M2 there is cancelled. So you just have to square 0.50, and then C2 here is also cancelled because C times C is C squared, and that's C squared, that's cancelled. So we are left with newtons, and we know that the unit of F should be newtons. So F2 on 1 is equal to, so just plugging that on your calculator, you would get 7.2 times 10 raised to negative 7 newtons. Okay, we're not yet done. Let's head on to the force that Q3 exerts on Q1. So you just have to do the same thing, plugging in the values. The value of K is 9 times 10 raised to 9 Newton meter squared per coulomb squared multiplied by, what's the value of Q1? It's 4.0 times 10 raised to negative 9 coulombs, and the absolute value of Q3. So you can see this is negative, but we are dealing with absolute value. Hence, what we want to do is remove the negative sign. So we ended up having 6.0 times 10 raised to negative 9 coulombs. Again, we remove the negative sign because we're dealing with absolute value. We should remove the sign. And the distance between Q1 and Q3 is 0.3. This is wrong. It's not 0.0. It's 0.3 meters. So that's 0.30 meters squared. Okay, again, so this is cancelled right here. So you're left with squaring 0.30. This is cancelled. You're left with newtons. And you were left with just plugging that on the calculator, the F3 on 1, or the force that Q3 exerts on 1 is equals to 2.4 times 10 raised to negative 6 newtons. Okay, but wait, we're not yet done because according to superposition principle, the net force is the sum of all this force. Now let's look at this word right here, vector sum. We know that these forces are vector quantities. Remember what vector quantities are? Vector quantities are quantities that has both the magnitude and direction. In vector quantities, F is always positive. So the sign for F is always, or its magnitude. We're talking about the magnitude here, okay? But the sign positive or negative that we add on F is talking about the direction. And since this is a vector sum, we have to consider the direction. Okay, so you have to consider direction before adding these values. So what you want to do is look at this picture right here. So we know that we have our Q2 here. Our Q2 is positive. We have our Q1 here. We know that our Q1 is positive, and we have our Q3 here, and we know that our Q3 is positive. We know that positive signs and a positive sign, like signs, repel each other. So Q1 and Q2 would repel each other, meaning the force that Q2 exerts on Q1 is away, going towards this direction. This is your F2 on 1. Why is it going towards this direction? Let's write it this way. Why is it going on this direction? Again, because Q2 wants to push away Q1. So if your direction is going this way, Q2 is basically pulling Q1 towards itself. And it doesn't want to do that because they're same sign. Same signs repel. So F2 on 1 is going towards this direction. Now let's look at Q3. Q3 is negative. And since we know this is negative, Q3 would want to pull on Q1. Therefore, the magnitude or the direction of F3 on 1, or the force of Q3 that is being exerted in Q1, is towards itself. It's going in the direction of Q3 because it wants to pull it. They want to attract each other. They're attracting each other. Therefore, direction of F3 on 1 is going in this direction. And as you can see now, F2 on 1 and F3 on 1 are both in the same direction. What we do now is in the vector sum, we have to add the magnitude and the direction. So if we have F2 on 1 going in this direction and F3 on 1 going in this direction, basically can use the same sign because the signs is talking about the direction. So it's up to you which sign you want to use. In this case, to make my life simpler, I'm going to use a positive sign. So both of these, since they're pointing in the same direction, I can use the same sign. So in order to find the F total, what I'm going to do is basically add F2 on 1 plus F3 on 1. And since I know that they're facing in the same direction, so what happens is it'll basically putting these two together. This is my vector sum now. F2 on 1 and F3 on 1. So we're basically putting them together, placing the tail of one of your forces onto the head of the arrow of the other force. So I would end up with having the value or the magnitude of F2 on 1 is 7.2 times 10 raised to negative 7 newtons plus 2.4 times 10 raised to negative 6 newtons. So I just need to add it to find the F total, which the value is 3.1 times 10 raised to negative 6 sorry, raised to negative 6 newtons. And the direction is towards going right. Sorry, not left. Directed right. So this is my answer. Okay, so I hope you guys understood what just happened. So again, vector sum, you have to consider the direction. So in this case, let's say hypothetically, I have Q2 as positive, Q1 as positive, and Q3 as positive. Q2 would want to repel Q1. So this is my direction here, F2 on 1. And as you can see, Q3 is positive also. So it wants to push Q1 away from itself. So this is my F3 on 1. As you can see, they're in a different direction now. So if I add this, they basically have the an opposite direction. So I can choose this as my positive and I can choose this as my negative, following the coordinate system, positive, negative sign. I can just follow the coordinate system to identify the sign. Again, the sign is for direction. It's not the value of your F. The magnitude F, these ones will always be positive. And if I want to put direction, that's when I use the sign. So if I add this, what will happen is basically F total is equals to, so I would have F2 on 1 plus, then I would have negative F3 on 1 because it's going in the negative direction. So basically in the end, I'm subtracting them, minus F3 on 1. See, this is why it's important. You have to understand the vector addition. You have to go back understanding vector addition or vector sum. So that's how you want to do and solve for superposition principle if you have three charges along a straight line. Okay, I hope you guys understood what happened. If you guys have any question, do not hesitate to message me. And for sample problem 4.2 and 4.1 would be the next part of the video. So may you guys have a great day and thank you so much.